In this video, posted on YouTube by Peter Boheckett, we see that the horizontal motion of the ball does not affect the vertical motion. Specifically, we see that all three balls take the same amount of time to fall to the floor, regardless the horizontal velocity with which they leave the table. My colleague, Michael, will elaborate on this idea in the next part of the video.
The height, the time in the air, and the initial vertical velocity of a projectile are all related in that they are all factors that determine the range, which is the horizontal distance traveled by the projectile. They are also factors which determines the vertical distance traveled by the projectile. The factors can be used in these two equations. The first equation is used to determine the vertical position of a projectile. Y equals the vertical distance traveled. Y sub 0 equals the initial height of the projectile. V sub y equals the initial vertical velocity. T equals time. A equals the acceleration due to gravity. On Earth, half of the acceleration due to gravity is 4.9. The second equation is used to determine the horizontal position of the projectile, which is also called the range. X equals the range. V sub x equals the initial horizontal velocity, and t equals time.
This is Company Bravo. We are located about 2,040 meters. We have engaged the enemy in combat. The front lines are about 2,000 meters from your present location. Can you send in support fire?
Roger that, support fire inbound.
The lieutenant in charge of the artillery unit was informed that the enemy positions were about 2,000 meters away. He was also informed that the U.S. troops were located about 2,040 meters. This means that he must be very accurate. If those projectiles went out too far, well, let's just hope his calculations are accurate. Due to the mountainous terrains of Afghanistan, his unit is located about 300 meters above the fight. He also knows that the velocity at which the artillery guns fires are at 200 meters per second. What he needs to know is how to position his guns in order for the projectiles to reach 2,000 meters. What is the angle at which the guns must be raised to hit their target? To figure out the angle at which the guns needed to be raised, the lieutenant begins to calculate. First, he figured out the horizontal velocity by using the Pythagorean theorem. Since the hypotenuse is 200 meters per second, the base leg must equal 200 times cosine theta. Then, he uses the horizontal distance equation. He plugs in 2,000 feet for the range and 200 times cosine theta for the initial horizontal velocity. He now knows that the time equals 2,000 divided by 200 times cosine theta. Next, he uses the vertical position equation and plugs in the values. I know this is not a very friendly equation, but since we have only one variable, it is solvable. Using a graphing calculator, the lieutenant discovers that he must raise the guns 76 degrees in order to reach their target. After raising the guns 76 degrees, he gives the command and rains down hell right upon the enemy.